Okay, at last, this is our first lab. So this is a very simple one, just an introduction and some of the basics, right, of spanning tree and the VLANs. Let me show you the topology here. Okay, so this is a very simple topology you'll find usually maybe in a campus network, small data center, where you'll have your core switches. Usually these are layer 3 switches where you're going to do layer 2, layer 3. Inter-VLAN routing and connecting to the one. For sure, you're going to run some routing protocol here. And then you connect your access switches, usually dual home as a best practice. And these access switches are going to be on layer 2 only. VLAN plan, very, very simple. Again, we are starting only most of the defaults here, just adding 3 VLANs, VLAN 100, 200, 300, right? For data management wireless, also some typical VLANs you may find in your network. Let's see how this looks like from a CLI perspective. First of all, I'm going to move myself so you can see the outputs. Okay. So I just run here, show spanning tree summary on all of the switches. You see we have our 3 VLANs we just created and VLAN 1, which is the default. And you'll also see on all of them that the default is rapid per VLAN spanning tree mode. Okay, this is the same on all of the switches. So now let's suppose I want to see which is the spanning tree that was calculated by the switches for VLAN 100. So let's do show spanning tree VLAN 100. I'm going to run this command on all of the switches, and we will start comparing all the outputs. Okay, here and here as well. Okay, so let's see. First of all, the first question is who is the root, right? Who is the root of the spanning tree? In this particular case, we see that access switch number 2, it says here, this is the root bridge, right? How do we know that? Because we know its address, which is 0C7E, all this, right? And we will see here that the root, here we also have which is the MAC address of the root. In this case, as this is the bridge, the root bridge, root ID and bridge ID are the same. Defaults, this is the default priority. As I mentioned, we didn't change any other configuration of a spanning tree, just defaults and adding VLANs. And you'll see on the rest of the switches that they are confirming that the root ID is 0C7ED3570, which is access switch number 2. So that means that if we go back to our topology, this root over here, access switch number 2, is the root for this network, which most sure this is not what you really would like to. And we can also see which ports, the port roles, the election of port roles from each switch perspective. Of course, starting with the root, all of its ports are going to be designated, right? Only 2 ports, gig 0, gig 1, connecting to the 2 core switches. But let's see, this is fun. On the core switches, we can see, for instance, on core number 1, it says, okay, port 1, 2 is the root. Let's see on the topology. Port 1, 2, that's fine. The port. So this is the root port. This is in forward, and of course, this is the root port because it's directly connecting to access switch number 2. And then it says that the rest of its ports are designated ports. From the core 2 perspective, it says also port 1, 2 is the root port. So going back to our here, 1, 2 is connected to access switch 2. That's fine. But you can check here that the Ethernet 1.8 and Ethernet 1.9 are alternate blocking ports. So that basically means that in this topology, the way spanning tree calculated the topology is saying that port 1.9 and 1.8 are actually blocked on this topology. So that means that traffic cannot run through core 1, core 2 through these main links. right? Which of course is not what we really want. And in the perspective of access 1, it says gig 00 is root, gig 01 is the alternate port in blocking mode. So that means that from access 1 perspective, this is the root. This is the root port, so traffic is going to flow like this, right? These are the ports that are enabled, but this port is blocked, right? So if we see the topology, we have this link active, we have this link active, this link active, all the rest are blocked, right? Okay, so this is what we get when we just leave all defaults without any kind of configuration, and we don't really choose which our root switches should be. So okay, this is definitely not what we want. All right, back to our second lab. In this case, we're gonna go one step forward. So create the same VLANs. We're gonna keep the 3 VLANs plus the VLAN 1, which is the default VLAN. But now we're gonna think a little bit more about how the network should behave, or basically how I want the network to behave, right? So, and we already know that spanning tree is gonna create different spanning trees depending on the mode I'm running. Usually if it's rapid spanning tree, per VLAN spanning tree is going to create one spanning tree per VLAN. And if not, I can use multiple spanning tree or MST. So I can choose which VLANs, so how many spanning trees I want the switches to calculate, and which VLANs will go to each of them. So if we go back to our topology, so let's suppose again our same topology, but now I want to think this a little bit more. So now I have the same VLANs, but now I'm going to group them in 2 different groups. I'm going to say group number 1, or instance as MST call them. Instance number 1, I'm going to put VLAN 1, 100 and 200, and on instance number 2 or group number 2, I'm going to put VLAN 300. Of course, if I have more VLANs, I can start, putting them on the 2 groups to make sure that I have the a balance, right, in terms of how many VLANs are on each tree, and I can also think about that in terms of how much traffic I may have on the different VLANs. For instance, maybe wireless is going to be heavy load traffic, but maybe management is not that hard, right? And I can put it with something else. And I know that what would be my best option here? It's, let's suppose that for instance number 1, or for my group number 1, in the case of access switch 1, I want that gigabit 00 is a root port, right? So I want this link active and this link blocked, but I want the opposite, right, for group number 2. So if I'm running VLAN on the traffic for VLAN 300, I want this link to be forwarding, and I want this link to be blocked. So that means that if I have traffic that comes to access switch 1, if this is, for instance, for VLAN number 100, it's going to use the gigabit 00 link. But if it's from VLAN 300, it's going to use gigabit 0/1. So I have a way to somehow balance, right, the traffic and use both links, right, and not only one, right? So kind of load sharing the traffic on my network, and somehow make sure that all my links are active. So it's more efficient in terms of resource usage. So let's go to our CLIs. Again, I'm going to move forward. I'm going to move me to the right so you can see, guys, the outputs. So first of all, I'm going to run, let me show you from scratch. So first, I'm going to run show span tree summary, the same that we run in the first lab, the same command on all of them. So you can see what are the difference here, the differences. So if you see, first of all, I'm running MST mode, right? So I'm no longer running rapid spanning tree, but MST mode, multiple spanning tree mode, the IEEE standard. And I'm having here 3 instances. Why 3? I only configured 2. Yes, I know. It's like instance number 0 is like the default instance, so it's going to be there always. No worries. You will focus on instance 1 and 2, which where I put the VLANs I do want. and on the rest of the switches are going to say the same, right? They are running MST, and in this case, I'm focusing on instance number 1 and instance number 2. So now I'm going to run show spanning tree MST. Okay, I'm going to run the same command on all the switches. This has a longer output, but we're going to go through this real quick. Same here, same here, same here. Okay, so first of all, as I was saying, right, the MST0 is kind of the default instance. So you'll have basically all the VLANs that you don't have configured are going to be there. Don't worry, that's fine. Then on then we'll have the 2 instances that we did configure. So if you see VLAN, the maps, right, or the groups of instance 1, in this case is VLAN 1, 100, and 200. And for instance number 2, we have mapped or put in the group VLAN 300, right? So basically, I will have 2 spanning trees, one for this group and one for this other group. In this case, this group has only one member, VLAN 300, but nevertheless, that's the idea, that I will have 2 spanning trees, right? And all my VLANs will split between those 2 groups. The same is going to be here for access switch 1 and 2. So we'll have MST0, MST1, and MST2. Again, the same mapping, right? For all of them, MST1, VLAN 1, 100, 200, VLAN 300 for MST2. And here, let's see the interesting part I was telling you. Let's check, right, for access switch 1, right, on instance number 1. I'm sorry, this is, let me put it here to see if we can see it clearly. Here. For instance 1, for VLAN 1, 100, and 200, I see gigabit 00, right? The port going to core 1 is the root port, so it's basically forwarding. And the port gigabit 0/1 going to core 2 is alternate blocking port. Okay? Why is that? Because I put that core 1 is going to be the root for instance 1, and core 2 is going to be the root for instance 2. I did that on purpose, playing with the priorities. Let me show you real quick. Here, show running config pipe include spanning, just for you to have a real quick an idea of the configuration of the basics. The same on core 2. It's taking a minute, but you'll see here what I want to show you on the configuration. We can see here on core 2, and well, here's core 1. So basically, I'm saying that for instance 1, right, core 1 is going to be the root, and for instance 2 is going to be the secondary root or the backup root. And the opposite, right, for core 2. For core 2, I'm saying that MST1, for instance, number 1, this is going to be the secondary root, but for instance 2 is going to be the master. It's going to be the root primary. So so that way, I'm actually telling the switches how I want the spanning trees to be created. So and access switches 1 and 2 actually follow that from the configuration perspective. I mean, from the calculation perspective, I want to say. So you see here, gigabit port 00 is the root, right, for MST1, but is blocking for going to core 2. But if we go to MST2, right, we have gigabit 00. Now it's the alternate, so it's blocking, right, for VLAN 300. It's blocking to core 1, but its root is forwarding for core 2. So that basically means that I'm having VLAN 300 going to core 2, and the rest of the VLANs going to core 1. The same happens here if I go to access switch 1, right? For MST1, gigabit 00 is root, so it's forwarding for VLANs 100, and 200 is blocking for core 2, and exactly the opposite for VLAN 300 is the port going to core 1 is alternate blocking, and going to core 2 is root, so it's forwarding. So you see here that with a simple configuration, in this case MST, I've created 2 spanning trees and split the VLANs into 2 spanning trees, and I'm having a better resource usage on my network.